Modern companies are usually subdivided into more than one divisions. And each of these divisions, they might be charged with a profit objective, maximize their own profit. So as a product moves through these divisions, on the way to the consumers, it's kind of sold or transferred from one division to another at what is called transfer price. So now, if each division is allowed to choose its own transfer price, then the final price of product to the consumers might not maximize the profits for the firm as a whole. All right, in such case, firms must pay special attention towards designing a transfer pricing mechanism that is geared toward maximizing the total company's profit. So, in short, the firms must design the price, a set price across different divisions, in order to so as to make sure the total company profit is maximized. In designing such a transfer pricing mechanism, one additional layer of complexity is that there may exist external market. For example, each division might be able to sell their product to the external market, or each division can purchase inputs from external market. All right, let's look at examples. Suppose the company has two divisions, C and A. The division C manufactures component division, and assembly division, which assemble the components into a final product. And let's look at, suppose, no external market, which means the output of component division must be exactly the same, must be equal to the inputs of the assembly division. So now we are faced with demand curve for the final product, one demand curve, but the firms has two marginal cost curve, one for the component division, one for the assembly divisions. Okay, so the idea here now is, okay, let's add these two marginal cost vertically up to get a total marginal cost curve, and follow MR equal to MC there, like this. Let me draw it here. So now we have quantity, final product. We know the demand. Let me draw this marginal cost curve first. So this is the marginal cost curve of assembly. This is the marginal cost curve of component, let's say. So what we do is we add these two curves vertically up. For example, at this level. So the marginal cost for the component is this many. Marginal cost for the assembly is this many. So add this on top of this. So we get this. So let's say it's this total. Okay. Then for the demand, we have downward sloping demand curve. From there, we work out the marginal revenue, which is twice steeper. MR equal to MC, that means this point, which means producing this many unit output. And for go from quantity up to the demand curve, get the price for the final product. And for the price of the component, we can just go from here, get this intersection point. So that's the component price. All right, this is how to set the price of the final product and the component product in order to maximize the profit for the whole company. All right, so if there's a external market, so what we have is the situation we have will be a little bit different. So now there's the component, there's a market, there's intermediate input market, the market for a component, and let's assume that the price there is PC. And we know that we know the marginal cost of producing component. Okay. So for the component division, it's going to follow this. The component division can sell their components in the market. So they are going to follow MI equal MC. So they are going to produce this many components. Okay. And for the assembly, so now the assembly divisions can also purchase components from the component market. So the marginal cost will be would be something like this, the different. So that's total. Okay. And then we have, let me use demand for final goods. Let's associate marginal revenue, MI equal MC, this many. That means this many units of final goods go from quantity to read out the price of final goods. Okay. And we know there's difference here. That means this division, this company is producing more component products than it required. So this company is also selling components into the market. All right, let's transfer pricing.